All right, let's practice Sigfigs for a minute, just identifying and finding out how many there are. Let's look at these at the moment, fairly identical, except we've just moved the decimal around, and in one case, left off some zeros. Well, rule 1 tells us that the 1, 3, the 5, and the 4 are significant for all of these. Rule 2 tells us any zeros between other numbers must be significant. So the 0 between the 1 and the 3 will count. And then rule 3 tells us that zeros that are right of a sigfig and right of another number will count. For our top one here, those two zeros only obey one of those two stipulations. They are rights of a sigfig, but the decimal, if it was there, would be way over here on the right, which means they are to the left of it. As a result, those two are not significant. There are only 5 sigfigs on our first number. For our second number, well, those zeros are right of a sigfig and they are right of the decimal. So both of those would be significant. Same for our next one down. Both of those would be significant. So these both have 7 sigfigs. And our lower one here, well, it actually looks a lot like number 3. 1.0354. It just doesn't have the zeros afterwards. It has 5 sigfigs. So what's the difference between those last two? Well, it would be the device. If your device was marked in 3 spots down from the decimal, you could have guessed the 4th. If your device was marked in 1, 2, 3, 4, 5 spots down, you could have guessed the 6th. Now, if something happens to fall exactly on 0, so say we have 9, 10, 11 on a scale, and your scale reading, boom, hits right there. Well, because the device is marked in ones, you should be able to go 1 decimal smaller. If I think it truly hit the 10 and didn't go any past, that it's not 10.1, it's not 10.2, that it's right on 0, then this is 10.0. The fact that there's zeros, in this case, they are significant. And so how would we see that from this? Well, the 1 would count. Rule 1 says any non-zero counts. Rule 2, well, there's no numbers in between other sigfigs. But rule 3 says, hey, one of those zeros, it's to the right of a sigfig and it's to the right of a decimal. So that N0 obeys rule 3, which now makes that middle 0 obey rule 2. So this device is an example of times where sometimes you do just have zeros at the end. When you happen to fall exactly on some value, the next decimal over is 0. You haven't gone any further past that value. And so the difference between our third and fourth value over here tells us how accurate the device was. Whatever device was used must have only been accurate to the 1,000th spot on that bottom one, but it was accurate to the 100,000th spot on the third one there. And so when we write a number, we leave it in the number of sigfigs our devices would have allowed. This means anyone else who comes across that number can understand how many significant figures went into doing or obtaining that number. Let's do a few more practices. If you've got 2.73, 0.01350, 12,730. Take a second, see if you can find a number of sigfigs in those. All right, well, the first one, 2, 7, and 3. Second one, 1, 3, and 5. Third one, 1, 2, 7, 3. Rule 1 says all non-zero numbers must be significant. We wouldn't have written them if they weren't. Rule 2 says all zeros between significant numbers. None fit that. So there's nothing here for Rule 2. Rule 3 says all zeros to the right of the decimal and the right of another sig fig. Well, my first zero I run into, it doesn't obey either. It's to the left of the decimal, and there's no numbers that it's to the right to. So it is not significant. Our second zero here, it is right of the decimal. However, it is left of all the other sig figs. So it fails to obey Rule 3. Our third zero, well, it is to the right of other sig figs, and it is right of the decimal. That one is significant. The idea was the device must have been marked such that we actually saw the 5 and we guessed the next one down. We wouldn't have written that 0 on the end unless we knew it. We would have written this as 0.0135 if we had guessed the 5 spot. If the markings on the device told us 5, we could have guessed that next one over. As we go down then to our next 0, well, it is right of sig figs, however, it is left of where the decimal would be. So while we didn't draw it in, the decimal would be 512,730, would be right after the 0. As a result, it's left of the decimal. It is not a sig fig. And so I have 3 sig figs, I have 4 sig figs, and I have 4 sig figs.